OP rolls a standard fair cubical die in successive trials. He stops when he rolls a 6 or has rolled the die 5 times, whether or not he rolls a 6 on the 5th throw. X is defined to be the random variable number of times the die is rolled. So if he gets 1 on the first go, he's going to stop there. So the probability he only rolls once is just 1/6, the probability of getting a 6. To have 2 rolls, you have to get a non-6 followed by a 6. So that's 5/6 multiplied by 1/6, giving us 5/36. To have 3 rolls, what we're going to need there is to have 5/6 for a non-6. Then the second one has to also be a non-6. And then the third one is a 6. So that's 25/216. So for 4 rolls, what we need is an extra 5/6 in here. And multiply. So that's 125/1296. Now where a lot of people went wrong was to put another 5/6 in here and give me whatever it was, 625/7776 or something. That's not right. This would then not be a probability distribution. He stops whether or not he gets a 6. So the way to do this one is to just do 1, take away all of the other answers. So take away 25/216, and then take away 5/36, and then take away 1/6. And that gives us 625/1296. So the probability of x being greater than 3 means 4 or 5. So that's 125/1296 plus 625/1296. So 125/1296 added to 625/1296, which gives us 125/216. Now, probability that x is greater than or equal to 2, given that x is less than or equal to 4, so that's x is greater than or equal to 2, intersection x is less than or equal to 4, divided by the probability that x is less than or equal to 4. So greater than or equal to 2 and less than or equal to 4 means these 3 values. So that's going to be 5/36 plus 25/216 plus 125/1296 divided by less than or equal to 4, which is all of these 4 added up, or if you like, 1 take away 625/1296. So we can calculate that. So if I put a fraction here, so what do we want on the top? We want the 5/36 and that should be on the top. Probably best off just doing it. So 5/36, and then we need to add to that 25/216 and add to that 125 over 1296, and on the bottom I've got 1 take away this one just here, and that gives us 455 over 671, and you could give that, if you like, as a decimal, 0.678. Now we have the expectation of x and the standard deviation of x. It's a calculated paper, so I might be tempted to make use of that, and we could use the statistics module, I think, in order to do that. So just going to clear anything that I've got in there at the moment, and so we've got x values of 1, 2, 3, 4 and 5, and then we've got 1 divided by 6, we've got 5 divided by 36, we've got 25 divided by 216, 125 divided by 1296, and 625 divided by 1296. And then we can go to calc one variable. X list is this one, the frequencies are in list 2, those are our probabilities, and OK that, and then the expectation of x is 3.589, we can just read it from here. The standard deviation is the sigma value, 1.576. So they're only 1 mark each, so you don't need to show too much in the way of working. Now this was a mistake in the test, but we did spot it and correct it. So expectation of x take away standard deviation of x. So if we go back to main, we have got, I'll go for decimal as well now, 3.589 take away 1.576. So we're looking at the probability that x is greater than 2.013 and less than 5.165, which is the same as x being greater than or equal to 3. Remember, it can't be 2, it says greater than 2.013, and less than or equal to 5. So we're looking to just add up the probabilities for 3, 4 and 5. So it's going to be 25 over 216 plus 125 over 1296 and 625 over 1296. So that's that one added to that one added to that one, and I should have gone for standard, 25 over 36. I don't think we've quite got the question in shot here. I'm just going to bring this over. The probability that OP gets a 6 with his 5th roll, given that he does 5 rolls. So probability 6 on 5th roll given does 6 rolls. that's equal to the probability that he gets a 6 on the 5th roll and does 6 rolls, which is just the same as getting a 6 on the 5th roll, over probability does 6 rolls. Okay, so this one would be a case of 5/6 to the power 4 multiplied by 1/6. On the bottom, you need this, 625 over 1296, which is the probability that he actually does 6 rolls. So, unfortunately, a lot of you actually had this as your answer in just there, what's on the top here. So, go back up to the top here. Let's stick an extra 5/6 in there. So that gives me 625 over 7776, and on the bottom we have the 625 over 1296. So I'm just going to copy that and bring it to there, and we'll divide that by 625 over 1296, and it gives us 1/6. So the expectation of y, well, that's just going to be 4 times the expectation of x, add 3. But you actually have to work it out. So just grab the calculator. I'm going to clear everything. So you actually have to do 3 times 3.589 and then add 3 to that. So maybe go for decimal. 13.767, and that doesn't look right, does it? No, it's 4 times, that's why. 17.356. And the standard deviation of y is just going to be 4 times the standard deviation of x. So 4 times 1.576. So 4 times 1.576, 6.304. And it doesn't actually matter that if you've got these values here incorrect. As long as you actually work this out with your value, you will get the marks. But you can't just write down this and expect to get marks.